is the idea of evolution through natural selection.
Darwinian evolution says not only that things have changed over time, but also that they change through a basically directionless natural process of survival of the fittest and random mutations.
That mechanism, and this is the controversial claim, is adequate to account for the manifest and observed complexity of living creatures. I say it's controversial because I think it's false. Not only do I think it's false, I think it's overwhelmingly false. On that level, when one actually has a theoretical proposal to make, however innocently expressed, however far from the standards of theoretical proposals one finds in physics, at that level there's a genuine controversy. There are issues to be determined, and they cannot be determined by injunction, by fiat, by declaration. They have to be determined by a very serious, careful, sober investigation of the evidence and the theory. There's no evading that. And that hasn't been done since Darwin wrote in 1859. There have always been critics, they haven't been heard. There's always been a countercurrent of disgruntlement and dissatisfaction that's never been adequately voiced. It's about time that's done. Nothing will happen, nothing bad will happen. What does the Darwinian theory say? What is the Darwinian anecdote? There are arbitrary changes, meaning that the changes are perfectly random. We have no idea when they will occur, and they're not linked to changes that have occurred. And after the changes have occurred, there's a deterministic process which culls out those changes that are valuable and saves those changes which are not, and extrudes those changes which are not. So the process is both one of sheer dumb luck, finding the right changes, and something that is not quite a matter of luck, that is quite deterministic, that is saving the valuable changes. Nonetheless, Darwinian theory suggests that each such episode, luck, change, is independent. It has nothing to do with the one that went before. So that in the abstract it could be modeled by what mathematicians call a random variable. At first cut, first approximation. When I talk about sheer dumb luck, I mean the amazing fact that these extraordinary, ineffably beautiful structures arise from what is at its heart a stochastic, that is to say, a random process. Now, no one is arguing, say, that if a tiger, a toothless tiger, develops a set of splendid dentures capable of biting its prey, it will improve its chances of survival. That seems obvious. It seems, in fact, so obvious that it's hard to imagine that a scientific theory is needed to explain it. But the essential point is that the structure of the theory is arguably stochastic. Each event, each episode, each bright, bursting episode of change is independent of the one that went before and independent of the one that's going to come after. That's what I meant by sheer dumb luck.
All genetic changes that we can map in, say, the genome of an organism. Antibiotic resistance. An organism is sensitive to a drug. You put it under the influence of the drug in an environment where the drug is present, and mutations will, actually they're pre-existing in that population that provide resistance, spontaneous mutations. Those are small changes. We can actually define what those changes are at the nucleotide level. Macroevolution would be imparting large new strategies or packets of information to allow a single-celled organism to change into a multicellular organism or a different body plan. You can have a reptile changing into a bird. So fairly dramatic, multiple changes. Microevolution is what we can demonstrate in the laboratory in real time of organisms changing due to different environments. The extrapolation, to macroevolution is a quantum leap, and I don't know if it's legitimate.
Whale, which is a mammal after all. It belongs to the same group of organisms as a dog, a human being, a chimpanzee, or a tiger. The interesting argument about a whale is that if its origins were land-based originally, then we have some crude way of assessing quantitatively, not qualitatively, but quantitatively, the scope of the project of transformation. The project is very simple. Let's put it in vividly accessible terms. You've got a cow. You want to teach it how to live all of its life in the open ocean, still retaining its air-breathing characteristics. What do you have to do from an engineering point of view to change the cow into a whale? This is crude, but it gives you the essential idea. Now, if the same question were raised with respect to a car, and you ask what would it take to change a car into a submarine, we would understand immediately it would take a great many changes. The project is a massive engineering project of redesign and adaptation. Well, the same question occurs with respect to that proverbial cow. Virtually every feature of the cow has to be changed, it has to be adapted. But since we know that life on Earth and life in the water are fundamentally different enterprises, we have some sense of the number of changes. Anytime a science avoids coming to grips with numbers, it's somehow immersing itself in perhaps an unavoidable, but certainly an unattractive miasma. Here's a chance actually to put some numbers on calculations. We're not talking about genetics, we're talking about simple numbers. The skin has to change completely. It has to become impermeable to water. That's one change. Breathing apparatus has to change. A diving apparatus has to be put in place. Lactation systems have to be designed. The eyes have to be protected. The hearing has to be altered. Salivary organs have to be changed. Feeding mechanisms have to be changed. After all, a cow eats grass, a whale doesn't. As I say, I've tried to do some of these calculations. The calculations are certainly not hard. But they're interesting because I stopped at 50,000. That is morphological changes. And don't forget, these changes are not independent. They're all linked. If you change an organism's visual system, you have to change a great many parts of its cerebellum, its cerebrum, its nervous system. All of these changes are coordinated. So when we're talking about an evolutionary sequence such as this, what's interesting about the cow to whale transition, and I'm just using this as an easily accessible idea. What's interesting about the cow to whale transition is that we can see a different environment is going to impose severe design constraints on a possible evolutionary sequence. How are these constraints met? If they're roughly 50,000. If they're 2 million constraints, how are those met? And what does this suggest about what we should see in the fossil record? To my way of thinking, if Darwinian hypotheses are correct, it should suggest an enormous plethora of animals, intermediary between, say, Ambulocetus and the next step. That won't solve all problems. One wants to know what's directing this change, if anything. But at least it will put it in the ballpark of a quantitative estimate, which is hardly ever done.
I wrote about 10 icons of evolution in my book. I could have written about more, but I had to stop somewhere. And the 10 that I wrote about were, first of all, the 1953 Miller-Urey experiment that purported to show that life could have begun spontaneously on the early Earth. And this is still found in most biology textbooks, even though geochemists decades ago decided that the experiment was unrealistic and really doesn't say anything substantial about the origin of life. The second icon was Darwin's Tree of Life, the branching pattern that would show how all organisms descended from a common ancestor at the root. And this is a theoretical statement, but it's presented in most biology textbooks as though it were a fact. The fossil evidence, for example, does not show this branching tree pattern. When you look at the different major groups of animals, they appear pretty much at the same time, rather than diverging from a common ancestor. The third icon I wrote about was homology in vertebrate limbs. If you look at the bone structure of the human hand or the human arm, you compare that to a whale's flipper or a bird's wing or a bat's wing, there are certain striking similarities in the bone structure. And Darwin considered this to be a result of common descent. But people before Darwin had noticed the same thing, and they called it, they attributed it to a common designer. Well, the truth is, it could be either one. The bone structure itself doesn't tell us. The fourth icon is Haeckel's embryo drawings, which purport to show that vertebrates are very similar as early embryos, and therefore this provides evidence for common ancestry. But in fact, the embryos are not similar, and Haeckel faked the drawings. The fifth icon that I wrote about was Archaeopteryx, a famous fossil of an ancient bird that had a long tail and teeth in its beak like reptiles, and for a long time was thought to be the missing link between reptiles and birds. Biologists no longer think that because there are too many differences between Archaeopteryx and modern birds, but textbooks tend to present it as the missing link anyway. The peppered moth is a famous icon of evolution in which moths supposedly changed color during the Industrial Revolution because dark moths were better camouflaged on soot-darkened tree trunks, and the birds couldn't see them, and so they ate the light moths and left the dark ones. And this is still used in many textbooks as a classic example of natural selection in action, when in fact biologists discovered in the 1980s that peppered moths don't rest on tree trunks in the wild at all, or normally. And so the textbook pictures have all been staged, and the story has serious flaws. Darwin's finches, another icon of evolution, are some species of birds on the Galapagos Islands that are very similar except for the size and shape of their beaks. And it's thought, and it's quite possible, that they evolved from a common ancestor because of having to eat different foods on the different islands. But the actual evidence shows us only that the beaks can change over a matter of years based on climate and diet. But the changes are temporary, they oscillate back and forth, and they don't go anywhere. So as evidence for the origin of species, Darwin's finches really don't work. Another icon of evolution is the four-winged fruit fly. Most fruit flies have two wings, but a series of mutations in a fruit fly can cause it to develop a second set of wings, very normal looking, but in fact there are no muscles attached to it, so the second set of wings is effectively dead. The fly is a hopeless cripple. It's kind of like having a small plane with an extra pair of wings tied to its tail. This is not the forerunner of a new race of insects, but an evolutionary dead end. The last two icons I wrote about were fossil horses and the ape-to-human picture. In both cases, there is some real evidence here. The important point in both of these icons, I'll mention them together, is that a very heavy dose of philosophy is laid onto the evidence in each case, mainly to persuade students that evolution is without direction or purpose. In the case of the ape-to-human icon, students are also told that humans, in effect, are nothing more than animals. Neither one of those claims comes from the evidence. Both of those are philosophical claims, but they use the evidence to make themselves appear more scientific than they really are. And so that's my criticism of those two icons.